Right, so now we have the tangent cube x secant 4x dx. Okay, so let's analyze first which type is this. Is the combination of tangent and secant. So our m is odd number, while our n is even number. Okay, so we have odd and even, so we are under type 3. So under type 3, we can use both the technique on how to solve the type 1 combination of tangent and secant, or we can also use the technique in solving the type 2 combination. Okay, so in this video, let us now first try to use the same technique we did in type 1. So we will isolate the tangent u secant u du as the derivative of secant. Okay, so once again, the derivative of secant is tangent u secant u du. Okay, so after we isolate the derivative of tangent u du, we need to um, to convert all the remaining uh, uh, tangent into secant form. That's why we will using the identity, which is equal to tangent squared u is equal to secant squared u minus 1. Okay, in order for us to make all the the form in terms of secant. Okay, since we will be using the secant and its derivative. Okay, so that is our technique. So first, let us now isolate the tangent u secant u du. So if we are gonna isolate the tangent x secant x dx, then what we have left with tangent square x and secant square x here, right? Because this 1 times our isolated part is this one, the tangent cube x secant squared, I mean secant, this must be 3, secant cube x times secant x, we have secant to the 4th x, and then our d of x. Once again, we isolate this because we will use it later as the derivative of the secant. That's why we need to convert this tangent in terms of secant. But how? Of course, by using its identity, which is tangent square u is equal to secant square u minus 1. Okay, so by doing that, what we have left here, tangent square x is equal to secant square x minus 1, and then this one we have secant cube secant x, then our last term here, our isolated part, tangent x secant x d of x. Okay, so as you can see here, our left part of the integrand is in terms of secant. That's why we can use this fact that the derivative of the secant is this. Okay, so that we can use it later in order for us to simplify our equation so that we can use our basic formula. Okay, so as simplifying this further, so we need to multiply the secant square x to the secant cube x. So we have secant square, secant 2 plus 3 is 5. Once again, when we multiply 2, then we will add its power. So we have secant to the 5 x. Then we have uh, minus 1 times secant cube x. So we have minus secant cube x. And then multiply by this term. Tangent x, secant x dx. Okay. So after that, we will gonna simplify it further by multiplying this part on the secant raised to 5x minus secant cube x. Okay, so by distributing this, so we have secant 5x and then this one tangent x secant x dx, then minus, now the second part, we have the integral of secant cube x, then multiply by this part once again, tangent x secant x d of x. D of x. Wait. Yan. And right after that, you can now see that me rewrite it again. Secant raised to 5. Secant raised to 5x is just equal to secant x raised to 5. Then tangent x secant x dx, then minus, we have secant x raised to 3, and then we have the tangent x secant x d of x. Okay, so at this point you can now realize that our technique, why we isolate this tangent to secant to du here as the derivative of this one, so that we can now apply our power rule. Okay, since if we let the variable u as our secant x, then we say that the derivative of this secant u here is tangent u secant du, or the derivative of the secant is tangent x secant x dx, right? Okay, so once again, going back to our integrand, so we have the u, this is our u, that is raised to 5. Then we have our du, which is the tangent x secant x dx. So applying that, we have du raised to 5, and then this whole term here is just equal to du. As you can see here, we can now apply our power rule. The same with this part, our second part. Have the integral of this secant x here is equal to u. So we have u, but it is raised to 3. So we have u raised to 3. And then this part once again is equal to our du. That's why we have u raised to 3 du. And we can also apply our power rule to this. So by doing so, we have u raised to 5 plus 1 is 6 all over 6, then minus u raised to 3 plus 1, we have 4 all over 4, and then our plus c. But we need to bring back the value of u. Back the value of u, which is equal to secant x. Okay, so our u is just equal to secant x raised to 6 all over 6. Then minus u, which is equal to secant x raised to 4 all over 4, and then our plus c. And this is now our final answer. So the integral of tangent cube x secant 4x dx is just equal to secant x raised to 6 all over 6 minus secant x raised to 4 all over 4, or you can use the other form, which is secant, then this one 6x all over 6 minus secant, this one 4x all over 4 plus c. Okay, so you can rewrite this interchangeably. Okay, so once again, let us review. We are under type 3, combination of tangent and secant. So our m is 3, which is odd, and our m is 4, which is even. So if we have this type, we can use the technique for type 1 or type 2. So on this video, we use first the technique in type 1, wherein we isolate the tangent u secant u du as the derivative of secant. Since we isolate this and we do the algebra, and then we found out that we have some tangent term here. That's why we need to convert this tangent here into secant so that we can use this later. Because if we have a purely secant term, then we can now use the power formula on the later part. But by transforming the tangent square x, we use the identity, which is equal to secant square u minus 1. And we apply that, and then we simplify our problem, multiply, and then we change variable as we let u as secant x, and then we got the derivative of the u, which is tangent x secant x. And we transformed this and found out that we can use the power formula and then apply the integration. And then after that, to finalize our answer, we bring back the value of u, which is secant x. So this is now our final answer. So on the next video, we will try to solve the same problem, but we will do the second technique. Okay, so see you on our next video.